Hey there everybody, and welcome back to the 5th episode of Creating a Multiplayer Game series using Unity3D and Red Hat OpenShift. My name is Bradston Henry, and as per usual, I will be your host for this evening. I'm excited to be here, and I'm excited to share what is next in our series. So today we'll be covering the process of creating our multiplayer game using the Unity3D engine. We're going to primarily be looking at the code behind what it takes to connect our Unity3D multiplayer game to our multiplayer game server, as well as building a very simple and very basic multiplayer game. For those of you who are new to Unity3D and particularly to game development, this will be a step-by-step process of how to create our multiplayer game. And even for those who are more experienced and have a lot more time in Unity3D, there'll be something you can probably learn along the way. And if not, hey, this is a great review of what you already know. So before we get into today's video, I just want to encourage you, if you have not already, to like this video and subscribe to this channel. I'm excited because I have a lot more series planned that I think will be beneficial for anybody who's interested in learning about tech, programming, game development, or anything else like that. I have a lot more coming down the pipe. And of course, I want more people to know about these series and what I'll be doing. So please, if you can, share, like, and subscribe. Now, before we jump into today's video, it's really important that you go ahead and download Unity Hub and Unity3D Engine, preferably Unity 2020, because that's what we're going to be using today in everything that we do. Today, we're going to be covering a lot of material, so this is going to be a pretty hefty video, but I know you guys are going to enjoy it, and I know there's going to be a lot that you're going to learn along the way. So without further ado, let's go ahead and jump into today's video and start creating our first ever multiplayer game. Alright, let's go ahead and get started creating our multiplayer game using Unity. So as you can see here, I already have Unity Hub open. Like I said a little bit earlier, it's going to be important that you have Unity Hub and Unity, I guess the game engine, actually on your machine. Otherwise, it's going to be hard to follow this tutorial. I just want to show you this page really quick. As you can see, I have 2 installs of Unity already on my machine, 2022 and 2020. I encourage you, if you're following along with me today, to use 2020. You can honestly use any version of 2020. I have a particular version, 0.3.23, but honestly any 2020 will work. You can also probably use 2019, 2018. I've done this in both of those versions and I'm pretty sure it works, but I can't guarantee you that. I'm very sure it'll work in 2020. If you want to add a different version, always know that you can click add here in Unity Hub and choose any of the versions that you would like. Alright, so let's go ahead and get started in creating our new multiplayer game project. So I'm going to go ahead and click the Projects tab here in Unity Hub, and I'm going to go ahead and click New. Here, I'm going to go ahead and make sure that I have 3D selected, as we're going to be wanting to make a 3D game. And I'm just going to call my game, my new project, the best game ever. And I'm going to say dash multiplayer, okay? Just so you know, okay? You can call it whatever you like. I'm just going to call it that for today. I might change it later as we go through our series, but let's go ahead and click create. Now, what's going to be happening as we're waiting for the project to be created is we're making basically a template project. Unity is just going to pull in a lot of stuff that we can use for making a project. And we're going to see some default assets, some default packages, giving us everything that we need to get started with our Unity project. Alright, our Unity project is now loaded in with basically a default sample scene and all the things that we're going to need to get started. So the first thing we're going to do is we're going to just go ahead and create a new scene. I'm going to go ahead and say File, and I'm going to say New Scene, and I'm going to create 3D, our basic built-in, and I'm going to say Create. I'm going to go ahead and click Save. So I'm going to press the Control Save here, Command Save, and I'm just going to name this scene called Multiplayer Scene, okay? Just so we know where we're going to be, I'm going to put in my scenes folder along with everything else that's in my scenes folder. All right, now I have my multiplayer scene. So let's go ahead and get started by creating our game. This is going to be a very simple game. So pretty much anybody who's used Unity before, this will be pretty straightforward and simple. If you've never used Unity, this will be pretty straightforward as well, as we're going to be doing some really basic functions in Unity. So what we're going to do is we're going to go up to this game objects menu here. Make sure that we're in our hierarchy here. I guess it really doesn't matter, but let's just make sure we're all ready to go. We're going to click Game Object, and we're going to click 3D Object here in this menu, and we're going to go ahead and click Plane. We're going to make a plane right out because the plane is going to act as our base scene, meaning when we have our game going, we're going to have players running around and moving. We need something for them to move on, so we're going to make a plane. I'm just going to move around in the world just kind of so we can get a better view of our plane. Okay, once we've made our plane, it's time for us to make our player. Once again, the plane is going to act as our scene, or basically the area that our player is going to move in, but we need a player to actually move. So let's go ahead and click Game Object here. Just like we did before, we're going to go to 3D Object, and we're going to go ahead and click Cube. So as you might have noticed, when we added our objects into our scene, our game objects, they're kind of placed more or less randomly. Sometimes they'll be placed at what's called the origin, which is 0, 0, 0 in the XYZ, coordinate system. But as you can see, my cube is kind of inside of my plane, and my plane it seems to be in a good place. But let's make sure that our plane and cube are in positions that we like. So in our plane, we're going to click it here in our hierarchy view. We're going to go over here in the inspector area, the inspector window, and we're going to make sure it says position 0, 0, 0. It already does on my end, but if it doesn't on yours, go ahead and switch that to 0, 0. Then we're going to go to cube. We're going to go to it, and we're going to put in here for our position values 0, 0.5, and 0. So the reason I'm doing 0.5 for the Y direction is because I want my cube to be a little bit above my plane, almost flush. So if I were to zoom in with my camera, you can see that it's kind of right here on the plane, and it looks really good. Okay, so now that we have our plane, which is our scene, and our cube, which is going to be our player, let's go ahead and get ready to set up our player. So first thing I'm going to do is I'm going to rename our cube here. I'm going to right click on it. I'm going to click rename, and I'm going to name it player. All right. We got an awesome player, but our player actually needs to be able to do something. Right now our plane and our cube will just sit there and nothing will happen in our game. It's not really a game. So what I'm going to go ahead and do is create the scripts that are going to make our player able to move within our scene. Adding this movement script is going to help us, as well as we're going to be able to use that information when we're sending it to our server, to actually see that our server is working. So things are looking great. Now we have a player in our scene, and we also have an area for our player to move. But as you might notice, the coloring of our cube, which is our player, and this plane are exactly the same, and it's a little bit hard to see. So let's go ahead and add a color to our cube so it's a little bit easier to see. So what we're going to do is we're going to actually navigate down here to this project window, and we're going to click assets here. So if you're not familiar with Unity, basically the project window and the assets window is where all of our project assets will be held. Okay, so what we're going to do is right click here on asset, and we're going to click create, and then we're going to go ahead and click folder, and I'm going to create a new folder. I'm going to call it materials. So the reason I'm calling it materials, because in Unity, how we manage our colors on objects, simple colors, is that we can make a material, and it's a very easy way to add color to an object. So once we're in our materials folder, we're going to make sure we open that up within our assets folder. We're going to right click in empty space. You see it says this folder is empty. We're going to right click anywhere in empty space. We're going to click create, and then we're going to click material. Now you'll see that we get the prompt to change the name. I'm going to go ahead and call our material blue, because I'm going to want our character to be blue. Now you'll see if you have selected the material, this new blue material, it's actually kind of blank. It's kind of a white color. You can see here in the bottom right corner of our screen. This is actually in our inspector view, but I want it to be blue. So what we're going to do is we're going to go under main maps where it says albedo, and we're going to go to this little color block here, and we're going to click on it. What we're going to do is going to just use this color wheel to make a blue. So I'm going to drag this little circle over to blue, and then I'm going to move my cursor here in this little square over to blue. And you'll see in real time our color is changing. So I'm going to go ahead and close this, and it looks like our color blue is great. Now, how do we get our color blue on our cube? It's very, very simple, very, very easy. All we're going to do is click and drag this blue material onto our cube, and just like that, our cube is blue, and it's a lot easier to see our player character in our scene. Now that we have our player character all set up visually, it's time for us to add some scripting to our player so we can actually move them around the scene. So what we're going to do is we're going to go ahead and create a new folder called scripts. Now, one thing you'll note about me is that I like to keep my projects organized and try to give appropriate folder names for everything that I'm doing, because it makes it much easier down the road to manage my project when I have a lot more scripts and a lot more going on. So what I'm going to go ahead and do is right click here on assets. I'm going to click create, and then I'm going to click folder. I'm going to go ahead and call this folder scripts. And in my scripts folder, I'm going to go ahead and make a folder that I'm going to call player. All right, let's go ahead and call it player. Now, one thing, if you watched my previous video, and I noted it in the comments, is that I made a minor error in some syntactical sugar, I guess you could say, as I was writing code. And there's a lot of code that we're going to have to cover today. So instead of me writing the code live, I'm going to go ahead and put some of the code into our project that we can review together. I'm not going to write it live so that I don't actually make mistakes like I did last time. And it'll be a little bit easier for you as a viewer to be able to follow along and see what's happening. So let's go ahead and double click and go into our player menu here. And so we have this empty player folder. So you'll see here I have a folder called our code on my desktop. I'm going to go ahead and open it. In here I already have some assets, particularly the scripts that we're going to be using for today, and also our server that we made in the last part of this series. But I'm going to go ahead and open up this Unity folder, and you'll see that I have quite a few things in here already ready just in case. I'm going to go ahead and open up the scripts folder. I'm going to open up this player folder, and I'm going to click and drag into our Unity editor this movement.css. Now, just for those who are interested, if you wanted to make this script from scratch, you can always just right click into our folder, click create, and then click C#, and then we can name our script movement. Now, I'm going to go ahead and open up this movement file. It already has code in it, and I'm going to walk through what's inside of it. So let me double click here on this movement file. All right, as you can see, I've just opened up my Visual Studio editor, and we already have some code inside of here. So you'll see that we have our public class name movement, and it's inheriting the mono behavior class, which is basically the basic class for any game object or script that we'll be using in Unity. Here we have a simple variable that is a float called movement speed, and this literally controls the movement speed of our character in the game. Now, you could set this movement speed variable to any value. It could be 10, it could be 1. 5 is just a good value. It moves pretty quickly, it moves at a good pace, and that's the way I like it, so I'm gonna leave it at 5. Now, within our script, we have this function called update. Update is basically a standard method that is provided by Unity through mono behavior that basically updates for every frame, meaning if our frame rate is 30 frames per second, every second this will update 30 times, okay? So inside of my update function, I have 3 lines of code, and they're pretty straightforward. The first is we're making this thing called a vector3. Basically, a vector3 holds an X, Y, and Z component. That's what we're going to need if we want to manipulate the position of our game object. And you'll see here in this move direction or movedir variable, I'm creating a new vector3, and I have in my first part of the parameters, which would count for our X vector, is input get axis horizontal. Basically, get axis is kind of a generic function or a generic method that allows us to quickly add in kind of movement controls or movement detection within our code. I'm not going to show it here because it's a little bit more complicated, but essentially horizontal is set up in our input window within Unity, and we can kind of set some parameters that allows us to control horizontal. In our case, horizontal will stand for A and D on our keyboard, and it'll also stand for left and right arrow on our keyboard. So every time that I press left or right or A and D, this will get some type of value. That value will range from -1 to 1. So A would be like -1 and D might be +1. Because we're not moving our character in the Y direction, meaning up and down, this is 0. And this is similar to how the horizontal works. For vertical, that's going to be W and S. And it's also going to be the up and down arrow. Okay, so we're making a new vector3, a 3-component vector using our inputs from our keyboard and the keys that we press. Now what we're doing is we're making this thing called new move direction, which is also a vector3. And what we're doing is we're multiplying our move direction by our move speed. Basically, this is just saying, hey, depending on what our input is, we want to move our character at this rate, at this speed. In our case, it's 5. Now what we're doing next here on this transform.position line is that we're actually taking the transform and the position of our player object, and every frame we're adding this new direction and we're multiplying it times time.tilde-time. Essentially, time.tilde-time just make sure that we're moving, I guess you could say, at the correct speed per second. So long story short is every computer kind of has its own speed that it moves at, depending on its GPU and its video card and all those things. This just makes sure that on any computer, our move rate, the position movement rate will always be the same no matter what. So you'll see here we have our new move direction and we're multiplying it by time.tilde-time. So basically what this does is moves our character's position depending on what inputs we put into our keyboard. Okay, now that we know how our movement class works, let's go back and actually add our movement script to our player object. So what we're going to do is we're going to go ahead and click player here in our hierarchy view, And we're going to go over here to our bottom right and click Add Component. In here, you'll see there's a little search bar. I already have some text in there. I'm going to erase that. And I'm going to type in here movement. And you can see our script movement appears. So we're going to go ahead and click on that. Once we click on that, you'll see that our movement script now appears in our inspector view of our player, meaning this movement script is literally attached to our player. One thing to note, there's plenty of different ways to add scripts to a game object, but this is probably the most simple and straightforward method to do it. All right, so let's test out our movement script. I'm gonna go ahead and press the play button here at the top. This will actually play our game so we can test it out. So let's press play. Play is gonna take a few seconds to load here, and then we can see if I press up and down and the arrows on our keyboard, we can move our player character. Let's go ahead and stop playing. Okay, now everything is set up, our player is moving, but the thing is, right now we have this game and it's awesome, but right now it's just a single player game. It's not connecting to our multiplayer game server. So now we need to add some new scripts that will allow us to connect our multiplayer game server to our multiplayer game. Meaning when we move our character's position here in the game, it'll be reflected on the server that manages our multiplayer game. All right, so let's go ahead and add in our multiplayer game scripts that we're gonna need to connect our multiplayer game to our multiplayer game server. Once again, I already have these scripts prepared, so I'm gonna go back to my folder and I'm gonna open up my scripts folder here that I have, and I'm gonna say multiplayer, and I'm gonna add two different scripts. One's gonna be called PlayerData.cs, and the other one's gonna be called SocketManager.cs. So what I'm gonna do is I'm gonna actually drag the whole multiplayer folder into our scripts folder inside of our project. So I'm gonna click and drag it in here, and now we have our multiplayer scripts. As you may have noticed, immediately once I did that, I got a red message or an error inside of our Unity editor. So let's go ahead and check out this error. Basically, this error is saying, hey, something's missing. We're missing the WebSocket Sharp code that we're gonna need to run the code that I just added. So I want to stop here for a second because this is really important. In order for us to run our multiplayer game and for it to connect to our multiplayer game server, it is important that we're using some type of tool or framework to enable WebSocket into our game. In our case, we're going to be using the WebSocket Sharp framework, which is available via GitHub. And if you're interested in learning more about it, I'll share a link in the description to the WebSocket Sharp GitHub, but I'll show you the page. Essentially, it's just a framework that allows us to use WebSocket in C#. One thing I want to note is that in order for us to use WebSocket Sharp in Unity, we're going to actually have to make what's called a DLL file, or basically a framework file that we can use within our code. I already have that file made and ready to go, but if you wanted to use it yourself and get some different version of it, you would actually have to come to this GitHub repository, pull down the code, and build it to create a DLL. Previously, you could actually get this DLL off of the Unity store, but I believe that is no longer available. All right, so let's go back to our Unity editor. So what we're going to do is going to go ahead and add this framework into our project. I already have it set up, I already have it built inside of my Unity files here outside of this project, and it's in this plugins file. So what I'm going to do is I'm going to select assets here, and then I'm just going to drag in this plugins file. And it's going to take a few seconds. It's going to compile the code, and everything should be good after that. All right, all the code has compiled and our plugin file has completely been submitted into our project. You can see here it's the WebSocket-Sharp DLL. Once again, that holds all the code and all of the frameworks that we're going to need to actually use WebSocket within our Unity project. So let's check out the new scripts that we just added to our project in our multiplayer folder. Let's first look at PlayerData. PlayerData actually does one simple thing. It actually sets up a structure for how our data is going to be sent to our multiplayer game server. As you may notice, here at the top, you'll see that I have this word serializable. Serializable basically allows us to essentially convert this particular data structure that we've created into different formats. This is kind of a benefit because instead of having to do some more complex method of trying to convert a particular type of data type or a particular type of object to a different type of data, serializable lets the system know that this is easily convertible to other types of things that Unity can convert. What that really means in our case is that we're going to want to take this player data structure, this player data object, and we're going to want to convert it to a JSON. And there's some JSON utilities that we'll be using that allows us to do that. But in order to do that, we need to make sure that our actual data is set up in a serializable manner. So what you'll see, there's only a few things in our data structure here, our player data object, and that's just going to really be our ID, our X, Y, and Z position, and a timestamp. As we go into the next set of code looking at our socket manager here, it'll make more sense. But this is basically player data, and this is what we're going to be using when we send data to our multiplayer game server. So let's go ahead and look at our socket manager. I'm going to go ahead and open it. So within our socket manager, we have quite a bit going on. I'm going to break it down into sections so that we can really understand what's happening. First, let's look at some of the imports or the code that we're going to be needing in order to run our code. So of course, we're going to need the Unity engine, as that's the default, Unity engine that runs basically most basic Unity code. We're also going to need WebSocket Sharp. WebSocket Sharp is once again from that DLL that we built and added into our project. The next thing to note is that we need this newtonsource.json.links. This is important to note because in previous versions of Unity, prior to Unity 2020, you had to actually install this framework, install this, I guess you could say, package into our Unity project itself manually. Now in Unity 2020, it's already included, but as you can see down here, I have this string called package URL. If you're using a earlier version of Unity like 2019 or 2018, I gave you the URL for you to install this package into your Unity project. Just as a quick aside, in order to install some type of package, you need to go back to your Unity editor, click Window, and then click Package Manager. And in there, you could manage any packages that you have in your project. All right, so let's go back to the code. Now that we've looked at the packages and the imports that are going to be used in this code, let's look at some of the variables that will be running throughout our code in Socket Manager. So we have three different variables that really matter to us. One is this socket variable, which is of type WebSocket. Now, as we already have done, we've imported WebSocket, but this socket variable will be what manages our connection, manages sending messages. This is crucial in order for us to communicate with our multiplayer game server. The next thing we have is our player game object. This is the player that we just created, that blue cube, and that's the one that we just added movement controls. In order for us to send data about our player to our game server, we're going to need to have a reference to our player in our socket manager code. Next up is our PlayerData object, which is of type PlayerData, and this PlayerData object essentially just holds the data that we want to send to our game server. Now that we've covered the variables that we're going to need for this particular script, let's start breaking down what's happening in the code. So let's start with this start method. Within our start method, we have a few things going on, but primarily we have two things: connecting to our server and receiving messages from our server. So let's start with connecting to our server. So as you see here, we actually have our socket variable getting defined. We're creating a new WebSocket connection to this particular location that will hold our WebSocket server. So once again, in this case, we're going to be doing on localhost because we built our server to run on localhost, but this could be an endpoint anywhere out in the World Wide Web. It could be a remote public server, a private server, or in later, in our case, it will be a server running in Red Hat OpenShift. Once we've created our socket object, what we're going to do is actually call the socket.connect command. As I mentioned in previous video, connect just essentially establishes the initial connection between a client and server. In our case, our client is going to reach out to our server at this particular location and say, hey, I'd like to set up an initial handshake. Is that cool? Let's do it. Once that original handshake is made between our client and our server, meaning our multiplayer game and our multiplayer game server, it's time for our multiplayer game to be able to receive messages from our server. And that's what this chunk of code here does. So in this chunk of code, we have our onMessage functionality, similar to what we had on our multiplayer game server. So in this particular case, in our onMessage function, we're only really particularly doing one thing. We're going to be looking out for data about ourselves that is sent from the multiplayer game server. If we recall from one of the earlier videos, we created a functionality where our server creates an ID for our player or for our client. And in this case, this code actually receives that information from the server. Things to note is that we're just checking to make sure that the data that we receive from the server is in a text format. More importantly, that it's a JSON string. And then from there, we're actually going to parse that JSON string so that we can use it within our code. Once we parse that JSON string, we're going to actually be looking for a particular element within that JSON string, or now that JSON object, which is our ID. And that ID is the ID that was generated on the game server. If that ID element is not null, meaning there's something there, we're then going to take that data and we're going to use this JSON utility that's called JSON utility from JSON to actually use the data that we got from our server and convert it into our player data structure or our player data object. We then take that player data object and we assign it to our local player data variable, which we'll be using to, update our player about itself. As you can see here, I have a simple debug that will print out in our console our actual player ID that we received from our multiplayer game server. All right, after we set up our on message, it's time for it to set up just simply our on close method. Basically, the reason we want this is because at the end of the day, the server can at any time decide to disconnect from us. Maybe it doesn't like us anymore. I'm just kidding. Or maybe it's just something going on with the client and it just needs to disconnect us. Here, we're just kind of catching that, and we're catching why it disconnected with us and, the reason in the code. And we're just debugging, hey, the connection closed. All right, now we have the basic startup or the setup for our connection to our Socket server. Now it's time to get into the moment-to-moment communication between our multiplayer game and our multiplayer game server. So you'll see here that we have our update function. Once again, this update function is called once per frame. It's very useful for us for communicating to our multiplayer game server. So what you'll see here at the top is actually some code that just basically says, hey, if our socket hasn't been set up, meaning we haven't done the initial connection, the initial handshake with our server, let's not continue any further. This is just kind of a safety measure to make sure that we're not running any code that's not necessary, especially if we don't have our socket set up appropriately. Once everything is fine and the socket is working appropriately, it's time to actually get into sending data to our server. So what you'll see first is a simple if condition checking some particular conditions that are important to us. The first condition is to check to make sure that our player is not null. The reason we want to check that our player is not null, because if we don't have a player, if our player doesn't exist, if our player is for some reason having an error, we can't possibly send data to our multiplayer game server about that player. So it's essential for us to already have our player set up and connected and created. The next thing we're checking with this and is that we want to make sure that our player ID has already been communicated to us from our socket server. What that means is that we want to make sure after that initial handshake that happened with our socket.connect, we want to make sure that we've actually received our ID from our multiplayer game server before we continue. Because if we don't have our ID from our multiplayer game server, the server won't know who's sending data or who's sending a message at any given time. So that is essential to making things work correctly. Once we're sure that everything is configured correctly and that our data can be sent appropriately to our server, we go ahead and get ready to set up the data that we want to send. So you'll see here in these 3 lines of code, what we're doing is we're actually taking that player data variable, that player data object, and we're assigning our current player's transform position to that object. So that's an X position, Y position, and Z position. And we're sending it, getting it ready to be sent to our server. After that, we're actually creating a timestamp of when this data was created. This is just more for tracking purposes and becomes a lot more useful as we get more code and more complex communications between our multiplayer game and our multiplayer game server. Once we have our position from our player and the timestamp that that position was obtained, we go ahead and use a JSON utility to change our player data object into a JSON string. This is important because our multiplayer game server is going to be expecting a JSON string. So we need to make sure that we format it correctly and send it. And we can use this JSON utility to do that for us and to prepare that data to be sent correctly. Once our data is prepared correctly, we send that data to our server. Once again, just know that this data is getting sent as quickly as it possibly can. So pretty much every frame, we're not necessarily going to catch every frame of data on our server, but we're going to send as much data as we can so that we can always be updating our server on the current position and the current whereabouts of our player. And finally, within our update function, we have a simple piece of code that just sends a simple message to our server. This is more of a debug thing. So if you were to press the M key in your keyboard, it would actually just send a simple message to our server, just letting us know that some type of message was sent from our client. Alright, so let's hit the last piece of information in our SocketManager script. Lastly, we'll see this onDestroy method. This basically gets fired whenever we close our game or if our game happens to close on its own. And what happens is we just go ahead and send a close message to our server, telling our server, hey, we're no longer in the game. Please remove us from the server. So you might be saying that was a lot, but really I wanted to make sure I broke down everything about this SocketManager server. This will make it a lot easier for you in the future as we continue to go deeper and deeper into making our multiplayer game server and how we can actually modify our multiplayer game to be more useful and have different types of communication with our server. With all that being said, let's go ahead and set up our game to actually communicate correctly with our multiplayer game server. So let's go ahead and flip back to Unity. The best way to do this in Unity is to go ahead and create an object called SocketManager that we'll use to manage our socket connection. So let's go ahead and create a new object. We're gonna go up here and click Game Object and create empty. This time we're just gonna create an empty object because all that we're gonna have on this particular game object is our script. And our script is gonna be everything that we need to manage our multiplayer game connection. All right, let's go ahead and rename this particular game object to Socket Manager. So let's go ahead and add our Socket Manager script to our Socket Manager object. So we're gonna go over here to our inspector view and click Add Component. So we're gonna go ahead in here and type Socket Manager. So let's go ahead and click that script and we'll see that our script is now added to our Socket Manager object. So as you might note, here you'll see a few different things, and particularly this is our variables that we added to our script. You'll see our player variable, and if you click this caret here, you'll see our player data and all of the data that could be associated to it. Really, we don't need to do anything with player data, so let's close that. The only thing that really matters for us right now is to connect our player to our Socket Manager script. So how do we do this? What we're gonna do is go over to our hierarchy view, click and drag our player onto this area that says None Game Object. That actually establishes the connection between our script and our player game object in our scene. And just like that, everything is set up and our multiplayer game is ready to go. But in order for our multiplayer game to work, it needs to have a multiplayer game server running. So let's go ahead and start our multiplayer game server that we created in the last part of this series. So let's go ahead and open our server from our code. So what I'm going to do is going to open up my our code folder because that's where I have my multiplayer game server housed. The next thing I'm going to do is I'm going to open up a terminal window. I'm going to go ahead and click terminal and I'm going to CD into our multiplayer game folder. I'm going to go CD and then I'm going to click and drag our folder into our terminal. And I'm going to go ahead and press enter. Once I do that, we're in our server folder and that means I can do a simple command to start our server up. That command we're going to use is node space server.js. And then we're going to press enter. And as we can see, our server is started and it's listening on port 8080. We already configured our Socket Manager script to look for port 8080 on our local host. So we're good to go. And all we need to do now is run our game and see our game working in real time. So in order to do that, when we click play, what's going to happen is we're going to see all of the data that we're sending from our game show up inside of our terminal window. So what I'm going to go ahead and do so I can see that happening in real time is I'm going to just move my window down here and I'm going to move my Unity game editor up here so I can see as my data is coming through from the game. So let's go ahead and click the play button. Once you click play, if you look in our terminal window, you'll start to see something miraculous. You'll see that we have a lot of things happening. Really what's happening is receiving data from our actual game that we're running. So I'm going to go ahead and move our player in the game. As you may notice down in the bottom right, that Y position and X position console log is actually changing. And just like that, we have set up our multiplayer game to connect to our multiplayer game server. So I'm going to go ahead and press stop as we have just proved that our multiplayer game is actually working. Now that we have our multiplayer game running and it connecting to our multiplayer game series, it's time for us to get to the final part of our series. In the final part of our series, we will be deploying our multiplayer game server out into the cloud using Red Hat OpenShift. This is going to be really cool because so far we've only made our multiplayer game and our multiplayer game server on our local machine, and we'll get a chance to see what it looks like to have our multiplayer game server running out in the cloud. As always, thank you so much for checking out today's video and tuning into the Creating a Multiplayer Game Server series using Unity3D and Red Hat OpenShift. And until next time, you guys have a great week, a great day, great evening, great morning, wherever you are in the world. I hope you're doing great. Thank you, YouTube family, for checking out this video. And until next time, peace.